Close your eyes for a moment and imagine this: 100 million years into the future. Not 1,000, not even 1 million, 100 million. A span so long that continents drift, mountains rise and crumble, oceans spill into new basins, and entire species are born, thrive, and die out without ever knowing we existed. That's the scale of time you're stepping into. And the question before you is simple yet haunting. What would be left of us? What imprint, if any, would our civilization leave behind in that distant tomorrow? You might think, surely something would remain. After all, we've covered the Earth in cities, highways, skyscrapers, and monuments. We've sent satellites into orbit and we've carved tunnels through mountains. Humanity has built with steel, glass, concrete, and even radioactive materials that decay on timescales beyond the human mind. But when you stretch your imagination to 100 million years, those creations, our proudest achievements, shrink to a flicker in the geological record. Start with the cities. Look around you now at the skyline of a modern metropolis. Towers of glass, concrete highways, and neon lights flickering against the night. It feels indestructible, doesn't it? But concrete crumbles under rain, glass weathers into dust, and steel rusts into reddish flakes. Left unmaintained, even the grandest skyscraper collapses in mere centuries. In a few thousand years, roots push through concrete foundations, rivers carve away the roads, and the jungle or desert swallows everything whole. After a million years, you would find little more than faint discolorations in the soil, an outline of foundations perhaps, or an unusual layer of chemical residue. But 100 million years? Cities as we know them would not just be gone, they would be forgotten by the earth itself. Mountains would erode into plains, plains would sink beneath oceans, oceans would evaporate and refill. The slow churn of tectonic plates would recycle entire stretches of crust into molten rock. The physical footprint of human cities would vanish into the endless process of planetary renewal. Yet not everything is erased so quickly. Some things, surprisingly, stand a chance of lasting far longer. Consider plastics. Right now, trillions of tiny fragments of plastic swirl in the oceans, buried in sediments and scattered across coastlines. Unlike stone or metal, these synthetic materials resist decay in ways nature never evolved to handle. Over time, most plastics break down into microfragments, but those fragments don't disappear. Instead, they become trapped in rock layers, sealed into sediments, fossilized into the geology itself. If a geologist 100 million years in the future were to split open a slab of rock from our era, they might find a thin, strange layer filled with polymer residues, brightly colored flecks, and chemical markers that scream of an artificial origin. A plastic horizon, a fossilized fingerprint of our age. And then there are our nuclear creations. Beneath deserts, mountains, and power plants lie spent fuel rods and waste sealed into containers, hidden deep underground. Some isotopes we've produced have half-lives stretching tens of thousands, even millions of years. Yet even those eventually decay into harmless forms. 100 million years from now, even the longest-lived isotopes will have passed into stability. What might remain is not the radiation itself, but the unusual chemical scars they leave behind, tiny anomalies in the ratios of certain isotopes detectable only by a scientist with knowledge and tools advanced enough to measure them. So what of monuments? Could the pyramids endure? Could Mount Rushmore stare out from cliffs into the far future? Surprisingly, not for long. Erosion is merciless. Rain, wind, frost, and the grinding of tectonics work slowly, but with infinite patience. Even the pyramids of Giza, already 4,500 years old, are fragile in geological time. In 10,000 years, they will be unrecognizable heaps of stone. In a million, they will blend seamlessly with the desert landscape. By 100 million years, those stones will have been pulverized, scattered, or buried beneath shifting sands. The great works of humanity will crumble, vanish, and be rewritten into geology. But there is one human mark the Earth cannot so easily erase: chemistry. The age of humans is carving a chemical signature so distinct that geologists of the future will recognize it instantly. The sudden spike in carbon dioxide, the global spread of rare earth metals smelted and concentrated for our technology, the strange isotopes released from nuclear tests, the abundance of synthetic fertilizers, pesticides, and heavy metals. Together, these form what some call the Anthropocene layer, a sharp, undeniable signal of a civilization that once reshaped an entire planet. And then the most haunting possibility, fossils. Fossilization is rare, but not impossible. Our bones, our teeth, even our engineered materials may leave behind traces. Imagine, in some distant desert, a paleontologist uncovering the fossilized remains of a human skeleton, compressed, mineralized, transformed into stone, or the fossil of a bird, its bones laced with microplastics, or a future reef made not of coral, but of concrete rubble fused with shells, forming a strange hybrid ecosystem that endured long after we were gone. Fossils, unlike monuments, whisper across the ages. So you stand at the edge of this thought experiment, staring 100 million years ahead, and you feel both awe and humility. Humanity may feel immense now, its reach stretching across the globe, but time humbles all things. Our grandest cities vanish in centuries, our proudest monuments erode in millennia, even our most dangerous wastes fade into stability. What lingers is not the skyscraper or the satellite dish, but the subtle fingerprints etched into stone, chemistry, and fossil. Our legacy in the scale of geological time may not be grandeur. It may be sediment, a thin layer, strange and out of place, telling future minds that once, briefly, there was us. Step further into that distant future, 100 million years ahead. By then, the Earth itself will not look like the world you know today. Oceans will have shifted, continents will have wandered thousands of miles, and coastlines will be unrecognizable. What happens to our civilization is not just a story of collapse and decay, but also of burial, entombment within the restless geology of a living planet. Picture this. Today's continents drift at a rate of just a few centimeters per year. It seems insignificant, barely the pace of a fingernail's growth. But stretch that rate over millions of years, and the distances become colossal. In 100 million years, the Atlantic Ocean, which now widens steadily, could close again. Africa may collide with Europe in its crumpling mountain ranges taller than the Alps. Australia might smash into Asia, reshaping coastlines entirely. New supercontinents could form, and with them, new oceans could open. Every collision would erase old landscapes, burying them under mountain belts, submerging them beneath rising seas, or grinding them down into sediments. So imagine a modern city, New York, Tokyo, London, Mumbai. Today they sprawl across coastlines, riversides, and fertile plains. But 100 million years from now, those very sites may lie at the bottom of oceans, thousands of meters beneath the waves. As tectonic plates shift, coastlines sink. Sediments wash over sunken ruins layer after layer, year after year. The remains of a skyscraper, a bridge, or an airport could be compressed into rock strata, flattened, mineralized, transformed. The future Earth won't see shining skylines. It will see curious bands of stone enriched with metals, plastics, and concrete dust, buried deep in sedimentary layers. Mountains, too, tell a brutal truth. Take the Himalayas, still rising today as India collides with Asia. In 100 million years, they will be worn down again by wind, rain, and ice. No matter how tall, no mountain resists erosion forever. And in their eroded debris, traces of human civilization may be swept into rivers and basins, compressed into fossil-bearing rocks. Imagine, far in the future, a limestone bed filled with shells, coral fragments, and embedded like an alien artifact, a chunk of rebar, or the imprint of a bottle, mineralized beyond recognition. Civilization itself would become just another ingredient in Earth's slow recipe for stone. Now think about oceans, the ultimate archives of time. Most of our waste, our plastics, our chemicals, our metals, sooner or later wash into the seas. They settle on the seafloor, joining the rain of dust, shells, and volcanic ash that accumulates in thin layers. Over tens of millions of years, those sediments harden into rock. Plastic becomes fossilized as thin streaks of carbon. Microchips, if they survive the descent, may lie crushed, their silicon lattices fractured but still strange enough to stand out. Radioactive isotopes might leave faint scars, tiny blips in future geochemical analysis. To future scientists, these anomalies could be as striking as the iridium layer we today use to mark the extinction of the dinosaurs. And here is where the imagination takes hold. Somewhere in a seabed that has long since become mountain, a paleontologist of that future age splits a slab of stone. Inside, they see a perfect fossil, an ammonite-like shell from their era's creatures. But next to it, something odd, the ghostly impression of a circuit board, mineralized into greenish stone, its pathways turned into copper threads of ore. They wouldn't know what it was. To them, it would be an alien puzzle. And they'd be right. It was an artifact of an alien civilization that existed long before theirs. Ours. But oceans are also the planet's destroyers. Seafloor crust is recycled relentlessly by plate tectonics. New ocean crust forms at ridges, while old crust sinks back into the mantle at subduction zones. This means that almost no ocean floor today is older than 200 million years. In 100 million years, much of today's seafloor will be gone, swallowed, melted, recycled into magma, with all its secrets obliterated. That's why, if anything of us is to endure, it is more likely to be preserved in continental crust, where rocks can last billions of years. On land, we stand a better chance of being remembered. Yet even here, the odds are slim. Most of our traces will be eroded, reburied, compressed, or melted away. Fossilization requires extraordinary luck, the right environment, the right burial, the absence of disturbance. Out of all the trillions of living things that have ever existed, only a fraction of a fraction become fossils. What are the chances for us? Perhaps a city drowned in mudslides, a landfill buried beneath volcanic ash, a highway entombed beneath desert sands. If anything survives, it will be not the beauty of our architecture, but its ruins, flattened, petrified, barely legible whispers in the rock. And here lies the irony. We live in an age of supreme visibility. We broadcast signals across space. We cover Earth with structures. We illuminate the night sky with our lights. Yet in geological time, we vanish almost without a trace. The grand monuments of Rome, the towers of New York, the dams of China, all swept away as if they had never existed. Civilization, it seems, is not eternal. It is fragile, and only by chance might fragments of our presence, buried in oceans, cradled in sediments, or sealed in stone, speak to that distant future. So you stand here, peering forward through 100 million years, and you feel the Earth's indifference. Continents shift, oceans drown, mountains rise and fall, and humanity, so mighty now, becomes but a chapter, a thin page, a faint whisper in the endless book of stone. Step deeper into the timeline. 100 million years ahead, our glass towers are dust, our highways dissolved, our monuments reduced to rubble. But technology, our tools, our machines, our synthetic creations, what of them? Can they endure where stone and steel cannot? Can the artifacts of an industrial age survive long enough to become fossils in the Earth's grand museum? Begin with the materials that define us. Stone and bone leave fossils. Shells harden into limestone. Even the delicate impression of a leaf can be pressed into shale. Now, picture our laptops, our phones, our satellites, our microchips. They too can fossilize under the right conditions. A buried computer entombed quickly in fine sediment may not remain recognizable as a computer. But over millions of years, the minerals within, silicon, copper, rare earth metals, could persist. They might recrystallize, fusing with surrounding rock. A microchip might survive only as a strange mineral inclusion, a tiny plate of patterned crystal embedded in stone. To future eyes, it would look like an unusual geometric anomaly. They might puzzle over it, the way we puzzle over fossilized stromatolites from Earth's deep past. And then there is plastic, our unintentional monument. Unlike wood or paper, plastics resist decay. They fracture into smaller and smaller pieces, but they do not disappear. Today, they swirl in the oceans, buried in sediments, frozen into Arctic ice. In 100 million years, many of these fragments will be long fossilized, sealed into layers of rock. Future geologists might split open a cliff and see a thin band dotted with colorful flecks of blue, green, and black, fragments of bottles, bags, and packaging. Plastics may compress into strange new rock types already glimpsed today. Plastiglomerates, natural stones fused with melted plastic, shells, sand, and coral. Imagine entire cliffs made of these hybrid rocks, forming a distinct stratum, a signature unlike any in Earth's long history. The legacy of plastic will not be grandeur, it will not be beauty, it will be strangeness. A geochemical signal, loud and unnatural, a layer that says, here was a civilization that took the carbon of ancient life, oil and gas, and turned it into synthetic matter that nature could not recycle. For millions of years, that signal will endure, even as our buildings and machines are erased. But plastics are not the only strange gift we leave behind. Think of metals, refined, smelted, concentrated in ways the earth never does on its own. Aluminum, rare in nature, is everywhere in our civilization. Cans, aircraft, wiring. In the ground, we've left massive caches of it, stockpiled in landfills and abandoned structures. Over time, much of it will corrode, returning to bauxite-like minerals. Yet, buried in deep sediments sealed away from water and air, some may endure. A million years from now, a future prospector might strike a vein of rock shot through with pure, unnatural aluminum, something no natural process produces. To them, it would be as alien as the iron beads found in ancient Egyptian tombs, smelted from meteorites before humans mastered fire. And what of glass? Glass is unstable, prone to weathering, dissolving slowly back into sand. Yet under rare conditions, buried in dry, stable environments, glass can survive astonishing spans of time. Volcanic obsidian from millions of years ago still lies sharp and gleaming. Could our windows, bottles, and screens survive the same? Perhaps, though not as windows, not as bottles, instead as nodules of strange silica, cloudy, fractured, scattered in sediments. The fossil of a bottle may appear as nothing more than a lump of quartz-like stone, its origin unknowable without a deeper science. Now think of landfills, the graveyards of our consumption. Beneath layers of soil and clay lie compacted mountains of refuse: plastic, glass, metal, paper, organic waste. Over centuries, these decay, compress, fossilize. In 100 million years, a landfill may appear as a bizarre fossil bed, a conglomerate of human debris. Imagine a cliff face revealing such a deposit. Rusted steel beams mineralized into red stone, plastics hardened into bands of color, fossilized food scraps mingling with mineralized paper fibers. To future geologists, it would be as clear as the coal seams we study today. Evidence not of ancient forests, but of a civilization addicted to consumption. But the strangest fossils may be our technology itself. Imagine a future scientist uncovering the petrified remains of a car, its chassis compressed into stone, its tires preserved as carbon-rich fossils, its frame leaving a ghostly imprint. Or the mineralized husk of a jet engine, its turbines fused into a lump of exotic metals. Or a fossilized phone, no longer a device, but a patterned inclusion in rock, mysterious as the trilobite to us. Technology in the deep future becomes fossil not of function, but of form. It will not work, but it may endure as an echo. And then, perhaps most haunting of all, satellites. Right now, thousands circle the Earth. They are humanity's first permanent mark beyond the planet itself. But in 100 million years, most will not remain. Radiation, orbital decay, collisions, they will fall, burn, disintegrate. Only a handful, perhaps those flung far into deep space, might survive as relics adrift in the cosmos. To the Earth, they are lost. But to the galaxy, they may be eternal. Our message in a bottle, tumbling silently between the stars. So when you step into this vision of the future, you realize Technology fossilizes strangely, not as machines, not as working artifacts, but as minerals, anomalies, sediments, and rocks. What survives is not the function, but the residue. The fossil record of our species will not be the pyramids or skyscrapers, but the layer of plastic, the seam of aluminum, the vein of silicon. Our civilization becomes geology, and in that, we join the long story of life on Earth, not as rulers, not as architects, but as fossils. Strange, colorful, unmistakable fossils. Step closer now. If our monuments crumble, our machines fossilize, and our plastics endure, then what else might testify to our presence 100 million years from now? The answer lies not just in what we built, but in what we changed. Civilization leaves scars, not only in stone, but in the chemistry of the planet itself. To future geologists, these scars may shine louder than any pyramid, louder than any fossilized city. They will whisper of an age when one species pushed Earth into upheaval. Think first of carbon, the breath of civilization. In just a few centuries, humans have burned through millions of years' worth of fossil fuels. Coal, oil, gas, all ancient sunlight compressed into carbon deep underground, released in a geological blink. The result is a sharp spike in atmospheric carbon dioxide, unprecedented in its speed. For future scientists, this will appear as a chemical fingerprint, a sudden change in carbon isotope ratios locked inside rocks and shells. Fossil corals, future limestone beds, and ocean sediments will preserve this chemical distortion, the way our own science reads the iridium layer from 66 million years ago. That layer told us of the asteroid that ended the dinosaurs. Our layer will tell them of us. An event, sudden and sharp, unlike the slow rhythms of Earth's natural cycles. And carbon is not alone. Nitrogen, too, bears our mark. Through fertilizers, we've doubled the amount of reactive nitrogen in the biosphere. Rivers, soils, and oceans carry this excess, depositing it into sediments. 100 million years from now, that nitrogen pulse may still be legible, a sharp deviation from the background, a clear sign that something artificial, something intelligent, once manipulated the planet's chemistry. Then comes the heavy metals, mercury, lead, cadmium, chromium, smelted, refined, and spread across Earth in unimaginable quantities. Some seep into sediments, some leach into groundwater, some fuse with soils. Over deep time, many will be buried, yet traces may linger. To a future civilization, they would appear as sudden anomalies, thin layers enriched in unnatural concentrations of metals, just as we today study the peculiar enrichments left behind by volcanic eruptions or meteor impacts. And perhaps the most chilling signal of all, radioactivity. In the mid-20th century, humans unleashed nuclear reactions not seen naturally on Earth for billions of years. Atomic bomb tests spread isotopes across the globe: plutonium, cesium, strontium, each a fingerprint of human technology. Though many decay in mere thousands of years, some leave behind daughter isotopes and geochemical distortions that last far longer. In 100 million years, most radioactive material will have long since decayed. But the signature of the nuclear age, its isotopic quirks, its scars in the ratios of elements, may still echo faintly in the rocks. A geologist of the far future, drilling into ancient strata, might pause at a curious horizon enriched in once radioactive elements, and they would know. Here, something unnatural happened. Now consider extinction. Civilizations are not remembered only by what they leave, but by what they take away. Right now, humanity is driving a wave of extinctions across the globe. Amphibians, insects, birds, mammals, plants, species vanish daily, their absence forming a great silence. The fossil record 100 million years from now will reveal this silence as a sharp boundary, a sudden thinning of diversity, a collapse of once rich ecosystems. To future paleontologists, this would look like a mass extinction event, the kind triggered in the past by asteroids, volcanoes, and supercontinents. They will not see our wars, our markets, our philosophies. They will see the sudden absence of species, and they will know something powerful, something disruptive lived in this age. It may be that our most lasting mark is not our buildings or technology, but this collapse of life itself. A boundary marked by dying forests, disappearing reefs, and scattered survivors adapting to a new world. Imagine the fossil record of that future, layers rich in cockroach carapaces, rat bones, and the hardened seeds of invasive weeds, while countless other species vanish abruptly. To future scientists, the sharpness of that boundary will be unmistakable. It will read as catastrophe. And yet, our scar is not only destruction, it is transformation. The biosphere is shifting, forced into new directions by us. Some species will thrive in the niches we created: pigeons, weeds, bacteria, perhaps even engineered organisms that persist long after we are gone. In 100 million years, new lineages will dominate, but in their genomes, echoes of human interference may linger. Synthetic DNA, altered proteins, engineered traits, they may pass through deep time, carried by descendants unrecognizable to us. Life itself will carry part of our legacy, encoded in strands of molecules more durable than stone. So when you peer forward, what you see is this: humanity becomes a chemical scar, a biological rupture, a geochemical fingerprint. The rocks will not tell of skyscrapers. The sediments will not describe empires. Instead, they will carry whispers of a sudden carbon pulse, an isotope anomaly, a mass extinction boundary, and a strange surge of plastics and metals. To future minds, the question will not be whether we existed. They will know beyond doubt that something extraordinary occurred. The question will be, what were we? A natural disaster, a planetary force, or a civilization that burned too brightly, too fast, leaving behind only scars for the Earth to remember? In that silence, across 100 million years, the Earth keeps its own truth. Civilization leaves not monuments but layers, not glory but chemistry. And in the patient language of rocks, our story becomes one line in a vast, unending book, a story written not in words but in scars. Step back for a moment and picture the monuments we build today. The Eiffel Tower gleaming in Paris, the Great Wall of China stretching across deserts and mountains, the pyramids of Giza rising against the Egyptian sun, the carved faces of Mount Rushmore. Stone, steel, concrete, monuments that feel eternal. They are the symbols of civilizations, the declarations of permanence. And yet, in the timescale of 100 million years, they are as fragile as chalk in the rain. Take the pyramids. Already ancient by our standards, nearly 5,000 years old, they have endured floods, winds, earthquakes, and the weight of shifting sand. To us, they appear indestructible. But erosion is slow and patient. Every century, rain seeps into cracks, sand abrades the stone, and temperature swings fracture the blocks. In 10,000 years, the pyramids will be little more than heaps of weathered rock. In a million, they will blend seamlessly with the desert, indistinguishable from natural hills. In 100 million years, their limestone blocks will be recycled, buried, compressed, transformed into new stone, or swallowed by shifting continents. The monument vanishes into the geology, its sharp lines forgotten, its story erased. Now consider the Great Wall of China, thousands of kilometers long, built over centuries, winding across valleys and ridges. Today, it looks like a scar across the land, a boundary you can see from the sky. But in the long view of time, that scar is temporary. Plants will grow through it. Bricks will crumble into dust. Rivers will carry the fragments away. And tectonic plates, always restless, will shift the land beneath it, twisting, burying, and fracturing the structure until not even its ghost remains. The Great Wall will not outlive the patience of erosion. Mount Rushmore seems even more permanent, faces carved into granite staring from a mountainside. Granite is tough, resistant. It survives longer, but 100 million years is relentless. Rain and frost will widen every crack. Entire cliffs will collapse. Rivers will cut valleys deeper. Mountains themselves erode into plains. In that span of time, even granite faces crumble into gravel, swept away by rivers, buried in sediments, lost to memory. The illusion of permanence vanishes under the weight of time. And then our modern skyscrapers, the glass and steel spires that define our cities. These are even more fragile. Steel rusts quickly, concrete fractures, especially without maintenance. Glass shatters, dissolves, or weathers into sand. Left untended, a skyscraper does not stand for millennia, it collapses in centuries. By the time 10,000 years pass, nothing remains but traces. And 100 million years, not even dust will carry their memory. Yet there is a deeper irony. Some of the oldest human made structures may outlast the newest. Megaliths, stone circles, temples cut from bedrock, they erode more slowly than steel towers. A simple pile of stones may endure longer than an entire metropolis, but even these, in 100 million years, vanish. Every stone you can imagine, no matter how massive, is eventually ground down, recycled, or buried. The earth does not care how sacred it was, how proud, how symbolic. All is leveled, all is erased. So what remains? Perhaps only the faintest of imprints, a discolored layer of rock where human structures once stood, a scattering of unusual minerals, concrete dust turned to stone, steel oxidized into strange ores, glass nodules buried in sediments. Future geologists might find these as odd patches in the record, artificial deposits unlike any formed by volcanoes, rivers, or seas. A strange layer where chemistry reveals intention, not accident. That would be our true monument. Not pyramids, not walls, not faces in stone, but an anonymous stratum whispering of civilization. And here's the humbling truth: permanence is an illusion. What feels eternal to us, monuments, cities, empires, is fragile in geological time. The earth is patient, and patience always wins. Our works stand only for a breath in the scale of deep time. But there is another layer to this story, one that cuts deeper. Our monuments are not only stone and steel, they are also stories, symbols, meanings. We build them to say we were here. Yet, 100 million years from now, even that meaning vanishes. No mind may remain to read them. No language may survive to translate them. No continuity may bridge our world with theirs. The monuments fall silent, not only in stone, but in significance. And yet, perhaps silence itself is a monument. The absence of our structures, the strange void where diversity once thrived, the peculiar chemical scars, all of these become testaments. In a way, Earth itself becomes our monument, not built by our hands, but reshaped by them, not meant to endure, but enduring nonetheless. So as you gaze forward, past the horizon of 100 million years, you begin to see our monuments for what they are: not eternal, but fleeting; not lasting, but echoing. The pyramids, the walls, the towers, they are sparks. The true permanence lies not in the stone, but in the scars left behind when the sparks have long gone dark. You stand upon a world that no longer remembers. The continents have shifted, the seas have risen and fallen, and the air itself hums with an unfamiliar rhythm. 100 million years is not simply a passage of years, it is a transformation so complete that the very bones of the earth seem to hum a different tune. You imagine yourself tracing the lines of this new geography, searching for traces of what once was yours and finding only silence. Yet deep beneath the ground, in strata layered like forgotten pages, remnants still wait, buried, crushed, transformed, but not erased. Civilization does not vanish in fire alone. Sometimes it drowns slowly, sinking under silt and sand, swallowed by deltas and oceans hidden beneath layers of mud. Imagine a city once filled with steel towers and the chatter of voices. Rain fell upon it, winds swept through it, roots cracked through its walls. Then rivers carried fine grains of sand, laying them down in sheets, year after year. Soon the city was buried, not under catastrophe, but under patience. Sediment became rock, and in that rock the outline of something man-made might endure. A tunnel sealed in clay, a steel beam fossilized in limestone, a fragment of glass fused into sandstone. You realize that the earth is not cruel, it is indifferent. Its processes do not aim to erase you, nor to preserve you. They simply move forward, layering one epoch over another, like blankets pulled across the shoulders of time. Yet within these folds, there is a strange kind of preservation. Not the kind that shows every detail, but the kind that leaves a shadow. A city becomes a stain in the strata. A skyscraper becomes a seam of unusual minerals. A highway becomes a ribbon of compacted stone with patterns no river could ever make. And then there is the ocean. You picture the ruins of coastal cities, long claimed by waves. Ships rest in sediments, their metal skeletons slowly encased. Some will dissolve completely, but others may linger in mineral form, copper and bronze, traces of alloys, fragments of ceramics. The seafloor is both a grave and a vault. It buries without hesitation, but in that burial, it sometimes preserves. If an archaeologist of some future species were to drill into these layers, they might not find a city intact, but they would find anomalies, structures too geometric, too ordered, too strange to be natural. What you begin to realize is that survival in geological terms is not about strength, but about accident. A clay bed in the right place, a landslide that covers rather than shatters, an anaerobic bog that keeps oxygen away, a desert that entombs instead of erodes. Civilization does not endure as it was. It endures as a series of imprints, like pressed flowers in a book too heavy to lift. And so, as you walk forward in your imagination, you feel the weight of that slow burial. It is not dramatic. It is not cinematic. It is relentless. The earth covers what is given to it, layer upon layer, until the world looks as if it has never known you. And yet, deep inside, your shadow is there, waiting, silent, pressed into the memory of stone. Close your eyes for a moment and try to stretch your imagination. Not to next year or the next century, but to a place so far into the future that even your mind hesitates. 100 million years, 100 million rotations of Earth around the sun, longer than the time since dinosaurs last walked the land, longer than the time it took for mammals to rise from tiny, shivering creatures into rulers of continents, longer even than the span between the first vertebrates crawling onto land and the earliest primates whispering in trees. Now, let yourself picture this. What will remain of the world you know? Of the roads you drive upon, the skyscrapers you gaze up at, the satellites you launch into orbit? What will be left of your civilization after 100 million years? The question feels almost absurd at first, like asking what will remain of a wave after it strikes the shore. You know that cities crumble, empires collapse, and even the strongest monuments eventually yield to time. And yet, buried in the depths of the earth, resting in sediments tucked within the stubborn chemistry of materials, there may still be echoes of you. Faint, ghost-like, but present. To begin, you must first grasp the scale of the clock you are winding forward. 100 million years. In that stretch of time, mountains rise and vanish. Oceans close, collide, and open anew. Continents drift thousands of miles, reshaping coastlines, fracturing and merging into supercontinents. The very face of Earth will be almost unrecognizable. The Himalayas, today thrust high into the cold skies, will be worn down to rolling hills or drowned by seas. The Atlantic Ocean, now expanding, may close in again, devouring the floor beneath the waves. Ice ages will come and go, leaving little trace but in the layered memory of rocks. And so you ask, what chance does a fragile skyscraper, a city of glass and steel, a digital record stored on magnetic tape or silicon wafer have in such a ruthless geologic span? Almost none. Picture a metropolis, perhaps New York, or Tokyo, or London. Skyscrapers stretch into the clouds, bridges span rivers, subways coil underground like steel intestines. Now fast forward 10,000 years. The glass has fallen, the steel has rusted, the streets are buckled by roots and soil. Nature has reclaimed the land. Push forward 1 million years. The weight of new sediments crushes what remains. Skyscrapers are now no more than veins of twisted iron oxide embedded in stone. 10 million years, tectonic forces bury, uplift, and twist. The traces are faint, scattered. 50 million, oceans advance and retreat, washing away evidence. And by 100 million, nearly everything is gone, nearly. For in this long stretch, your civilization becomes not a city, not a monument, but a whisper imprinted in the geological record. a strange layer, a boundary, a thin smear in Earth's crust that tells a story of something extraordinary that once lived and built and altered its world. Consider plastic, the cheap, disposable material that saturates your oceans and piles in your landfills. Today, it seems like a curse. But in deep time, it becomes something else, a marker, a signature. Plastics may decompose in surface conditions, but when buried, transformed under pressure, they form a new kind of rock. Some scientists already call them plastiglomerates, fused mixtures of sand, shells, and melted plastic. Imagine those hardened clumps buried in sediments. 10,000 years, 1 million, 10 million. They remain, hardened into stone. Future geologists, be they human descendants or some other intelligence, may find them as unmistakable evidence that once a civilization capable of chemistry and industry walked this earth. Then, there is the question of carbon. The fossil fuels you burn, the forests you clear, the gases you release into the sky, these leave fingerprints, chemical scars in the strata, a sudden spike of carbon dioxide, anomalous isotopes, signs of warming seas, of mass extinctions triggered in an instant of geologic time. If the dinosaurs were ended by an asteroid, then your civilization may be remembered by the thin, dark line of a carbon surge, a boundary etched forever into stone. And what of your monuments? The great pyramids of Egypt, built of limestone blocks, already erode under mere thousands of years of wind and rain. Mount Rushmore, carved into granite, might endure a little longer, perhaps a few million years before its faces are worn smooth. But after 100 million, even granite yields. The carving dissolves back into ordinary mountain. The only chance such works survive is if they collapse into a sheltered cavern or are entombed by sudden sediments, hidden and preserved like fossils. Yet fossils themselves give you hope. Consider the bones of dinosaurs, delicate structures, preserved not because they were strong, but because they were swiftly buried in the right conditions. Could your skyscrapers, your cars, your bridges be fossilized? In rare cases, yes. A buried city, sunk by earthquake or sea, might leave strange fossils, voids in rock shaped like beams or mineralized remains of machines. Even microchips, compressed into slivers, may leave curious metallic inclusions. Imagine a geologist in the distant future splitting a slab of rock to reveal a patterned lattice of silicon, the fossil of a computer chip, incomprehensible yet undeniably artificial. Still, the Earth is relentless. Subduction zones swallow continents whole, sediments transform into metamorphic rocks, oceans grind down coastlines. The majority of what you build is destined not just to be buried, but to be erased, recycled into the endless churn of geology, which means that the record left behind will be patchy, fragmentary, a handful of clues scattered like puzzle pieces across a planet forever remaking itself. Pause here and let the weight of it settle upon you. 100 million years from now, if some intelligence digs into the ground, what will they find of you? Not your libraries, not your languages, not your vast digital archives of knowledge, but a handful of oddities. A band of carbon-rich rock, a layer flecked with strange plastics, traces of metals and alloys unknown in nature, perhaps even a few fossilized remnants of structures, enough to hint that something once lived here. Something clever. Something capable of reshaping its world. And you realize something humbling. In the endless churn of time, your civilization is but a flare, brilliant, brief, and swiftly consumed. Yet still, in that great silence of the future, echoes remain, and those echoes may speak of you long after you are gone. Imagine the first million years after your civilization falls silent. Not 100 million yet, just the first stretch of deep time. Already, the silence is overwhelming. Your cities are gone, not by sudden cataclysm, but by the slow, patient reclaiming of Earth. Steel rusts, concrete fractures, glass turns to sand. Roads, once proud lines that cut across continents, are swallowed by soil, forests, and rivers. The great towers, symbols of power and ambition, fall one by one, leaving mounds of rubble that nature wastes no time in cloaking with green. Within 10,000 years, no skyline remains, and yet fragments linger. If you walk in this imagined future through what was once Manhattan, you do not find streets. You find marshland, forests, and perhaps small hills where foundations once stood. Beneath your feet, though, are the bones of a city, subways entombed, tunnels filled with sediments, rusted skeletons of bridges now encased in stone. Buried deep, some traces survive, waiting for discovery. Now stretched further, 1 million years. Volcanoes have erupted, rivers have shifted course, ice ages have advanced and retreated. By now, the buried ruins are compressed beneath meters, even kilometers of sediments. And yet, odd patterns endure. A band of unusual materials mixed into rock, aluminum, concrete, plastics. Materials Earth never made on her own. Geology has swallowed them, but not digested them entirely. They remain, like indigestible fragments of a meal, locked within stone. Here, you begin to realize something astonishing. Earth is ruthless, yes, but she is also an archivist. She keeps strange things, fossils, after all, our bones transmuted into minerals, stone remembering flesh. Amber preserves insects with delicate wings intact for tens of millions of years. Ice remembers the breath of ancient atmospheres. If nature can save such fragile things, what might it save of you? Consider the oceans. Today, your seas are filled with the detritus of human life. Plastic bottles, fishing nets, microfibers, beads, fragments too small to see. These sink, scatter, drift to the seafloor. There, they mix with shells and silt by forming layers that harden into future sedimentary rocks. 10 million years from now, these plastic-flecked layers remain, stubborn signatures that something once polluted the seas. 100 million years from now, if those sediments are not swallowed by tectonic forces, a geologist might split a rock and find the unmistakable geometry of a bottle cap embedded forever in stone. But oceans do more. They record chemistry. Already, the carbon you have released into the air dissolves into seas, altering their balance, causing acidification. Coral reefs bleach and die, and in their skeletons, the chemistry of collapse is written. These reefs buried fossilize, and in the distant future, they whisper, here was a moment when the ocean's balance broke. Here was a time of change caused not by volcanoes, not by asteroids, but by an intelligent species burning the ancient past of its planet. Yet perhaps the most haunting traces are not of plastic or carbon, but of life itself. You, your bones scattered in cemeteries, cities, and mass graves. At first they crumble, but some are buried fast enough, sealed in mud, clay, or volcanic ash, that they fossilize. Not millions, perhaps not billions, but some. A femur here, a tooth there. Encased, mineralized, they endure. Imagine 100 million years from now, an explorer splitting open stone to reveal the unmistakable curve of a human skull. Not an ordinary fossil, not a creature of natural evolution, but something else. Something that built, destroyed, and vanished. And then comes a deeper truth. The earth, patient and unyielding, does not merely remember fragments. She transforms them. Your plastics become rocks. Your steel becomes veins of iron oxide. Your cities become fossils of architecture. And in this transformation, your civilization crosses a boundary from history into geology. You are no longer a culture, no longer a memory. You are a layer, a stratum, a permanent silent chapter in Earth's geological book. Pause here. Feel the strangeness. You live, you build, you believe your work's eternal. Yet to deep time, you are a trace, a peculiar layer sandwiched between epochs. To the beings of the far future, if they exist, you are not a people, you are a mystery, a geological anomaly, the strange civilization that burned bright, altered a planet, and then disappeared. And this realization cuts two ways. On one hand, it is humbling. Your monuments vanish, your words dissolve, your stories die. On the other hand, it is immortalizing. For though you vanish, you leave fingerprints in stone, a whisper that says, we were here. Once, long ago. Now stretch your imagination further, not 1 million, not 10, but 100 million years. Entire mountain ranges have risen and eroded, oceans have vanished and returned, continents have wandered across the globe, colliding, splitting, dancing in their endless tectonic waltz. The earth has been remade, and still, in hidden places, fragments of you remain. The silence after collapse is not empty, it is full of ghosts, and those ghosts wait in stone. Picture the earth not as it is now, but as it will become, alive, restless, forever reshaping herself. The continents you know, North America, Africa, Asia, Europe, Australia, South America, are not fixed. They ride atop the slow, grinding plates of the lithosphere, moving at the pace your fingernails grow. And yet, given 100 million years, that pace redraws the entire face of the world. Imagine standing on a supercontinent, not Pangea, the great gathering of land that existed 200 million years ago, but something new. Geologists call it Amasia, or sometimes Novopangea, a hypothetical landmass that could form when continents converge again. Whether it is true Amasia or some other arrangement, the point remains. 100 million years from now, coastlines you know will not exist. Seas will have closed, mountains will have risen, and oceans will have vanished. Now ask yourself, what happens to your civilization in such a restless world? Take New York City. Today it clings to the edge of the Atlantic, but the Atlantic itself is young, a mere 200 million years old, and in another 100 million, it may close. If so, the ruins of New York, buried beneath sediments, could be carried inward, crushed by colliding plates, swallowed into mountain ranges, or even dragged into the Earth's mantle by subduction. Imagine a fossilized skyscraper, its steel beams transformed to hematite, its glass to quartz, descending into the depths, vanishing forever in the slow recycling of crust. Or picture the Pacific Ocean. It is ancient and vast, yet even now it shrinks as the Pacific Plate dives beneath its neighbors. In 100 million years, much of the Pacific may be gone, devoured by subduction zones. Entire archipelagos, whole island nations will vanish beneath Earth's crust, their ruins ground into nothingness. The geological record will not remember them at all. But here is where the story turns. For not everything is lost in subduction. Some regions escape. Some pockets of crust are preserved, never dragged beneath. In these sheltered places, fragments of your world may linger. Perhaps a landfill, entombed in sediments, becomes a fossil bed of civilization. Plastics, glass, and steel sealed like relics. Perhaps a city buried by volcanic ash is preserved, the way Pompeii remembers Rome. Perhaps deep within a desert basin, sediments quietly pile upon ruins, compressing them into a geologic museum for the far future. The shifting continents also create new opportunities for preservation. Rivers cut deep valleys, then flood them with silt. Mountains erode, spreading sediments across lowlands. Inland seas form and vanish, leaving thick deposits that trap fossils. In these processes, some trace of you is caught, sealed, and held for tens of millions of years. The Earth, while ruthless in erasure, is also generous in preservation, if the timing is right. But let yourself imagine even further. Imagine beings, whatever they are, walking this future world. They split rocks open, they study the strata, and what do they find? They find a thin, peculiar layer sandwiched between more ordinary sediments. They find isotopic anomalies, carbon levels spiking unnaturally, nitrogen cycles broken, heavy metals in odd concentrations. They find plastics fused with shells, forming rocks that never existed before. They find traces of rare earth elements, once mined for your electronics, now scattered in sediments like artificial meteorites. They may even find the fossilized remains of your creations, machines, architecture, perhaps even your bones. And yet the geography around them is alien. The continents are joined into strange configurations. Mountain ranges rise where oceans once lay. Fossilized whales lie in deserts. The echoes of your world are displaced, scattered, and altered, but still there. Pause and feel the scale of this. You build your cities as though they will stand forever. You carve mountains, raise towers, dig tunnels, and imagine permanence. Yet in 100 million years, they are passengers, tossed, crushed, scattered by the wandering continents themselves. This is not merely the erosion of monuments. This is the reshaping of the very canvas upon which your civilization was painted. The world itself is the artist, and time is her brush. And still, despite this restless drift, fragments endure, oddities in stone, fossils of machines, layers of chemistry. The record of your civilization does not remain where you left it. It travels, carried on the wandering plates, hidden in the folds of mountains, buried deep in deserts, or preserved in the quiet bottoms of seas. 100 million years is enough to erase almost everything, but it is also enough to enshrine what little remains in ways you cannot imagine. The continents drift, but the whispers of you drift with them. Think of the monuments you know: the pyramids of Giza, the Great Wall of China, the skyscrapers of New York, the temples of Angkor, the statues of Easter Island. Each one feels eternal, as though carved against the decay of time itself. But in truth, they are fragile. They exist only because you live in a fleeting slice of history. Stretch the timeline to millions of years, and their permanence dissolves like salt in water. Start small. A single century of abandonment is enough for nature to creep in. Roots split stones, vines twist through cracks, water seeps, freezes, and prees blocks apart. In mere hundreds of years, even the most revered monuments show wear. Now, give the earth 1,000 years. Bronze statues corrode to green powder. Concrete crumbles to gravel, iron beams rot into rust, staining the soil. Marble columns weather, their carvings lost. Your proudest structures fade to ruins. And after 10,000 years, the pyramids perhaps still stand, but smaller, eroded, their sharp lines dulled into slopes of rubble. The Great Wall, reduced to scattered mounds, indistinguishable from hills. Skyscrapers long since collapsed lie buried beneath soil and forest. At this scale, the monuments of your age are already whispers. Push further to 1,000,000 years. Here, erosion becomes relentless. Rivers carve valleys, floods wash plains clean, glaciers grind the land into raw stone. Whatever monuments remain are toppled, shattered, carried away as gravel. Even the pyramids, those stubborn triangles of stone, are little more than sand. And yet, the earth is not only a destroyer, it is a recycler. These eroded stones do not vanish. They become sediments pressed into new rocks. The marble of a temple may someday be reborn as limestone in a cliff. The granite of a carved face may be relayered in mountains yet unborn. Your monuments do not survive as you knew them, but their matter endures, scattered, recombined, transformed. But what about your most ambitious creations? The skyscrapers, the dams, the vast bridges, they fall even faster. Built of steel and concrete, they are strong against weather in the short term, but weak in the face of deep time. Steel rusts and flakes away. Concrete dissolves under water, fractures in frost, and breaks under pressure. Within tens of thousands of years, nothing remains but rubble. Within millions, even that rubble is consumed into sediments, indistinguishable from natural rock. And yet, imagine a rare accident of preservation: a dam buried by a landslide, a city entombed in ash from a catastrophic eruption, a monument submerged and sealed by silt. These could endure as fossils of architecture preserved in stone as Pompeii preserves Rome. But such cases are rare. For most monuments, the story is one of vanishing. Pause and imagine this: 100 million years from now, a future being, human or otherwise, explores a mountain range. They split open a slab of stone. Inside, they find strange impressions, patterns too geometric to be natural, perhaps the outlines of bricks, or the ghost of rebar, or the cross-section of a staircase. To them, it is as mysterious as the trilobite is to you, an imprint of something once alive, once crafted, now long gone. Even your grandest works, spaceports, towers, colossal statues, are not immune. Mount Rushmore, carved into granite, might endure the longest. Its faces could stare out for millions of years before weather smooths them into anonymity. But 100 million? The mountain itself may have been worn flat or swallowed into Earth's crust. The carvings are gone. And so you confront the truth. The monuments you build to outlast you are among the least likely traces of your civilization to endure. They are too exposed, too vulnerable, too easily broken by water, wind, and time. The irony cuts deep. What survives best are not the symbols of power and pride, but the overlooked detritus: plastics, alloys, chemical residues, and buried waste. It is humbling. You raise monuments to proclaim eternity, but it is your garbage that endures. The story of your civilization is written less in temples and towers and more in the stubborn persistence of bottle caps, microfibers, and radioactive isotopes. Yet there is a strange beauty in this, for when those future beings uncover the remnants, they will not see only ruins. They will see patterns, layers, anomalies, evidence of something remarkable, that intelligence once walked the earth, that a civilization once rose, altered the planet, and left its fingerprints across stone and time. And perhaps in that moment they will pause. They will feel the echo of you, not in the grandeur of monuments, but in the quiet persistence of traces. Monuments fall, time is merciless, but memory, etched in geology, remains. Close your eyes and imagine this. 100 million years have passed. The mountains have risen and crumbled, oceans have opened and closed, forests have grown, vanished, and regrown. Every monument you once raised has fallen silent. And yet, deep within the earth, buried beneath layers of stone, a whisper glows. A whisper not of stone or steel, but of atoms, unchanged, unyielding, still radiating their presence across the abyss of time. This is the legacy of your nuclear age. When you split the atom, you did more than create energy. You created signatures, unique isotopes that nature does not produce in abundance. Strontium-90, cesium-137, plutonium-239, uranium-236, each with a distinct half-life, each decaying on its own schedule, each leaving fingerprints in the strata. Even after tens of thousands of years, their presence is measurable. Even after millions, some persist. And in 100 million years, though most will have decayed into stable elements, the evidence of their sudden appearance, clustered in time, scattered across the globe, will remain. Picture a future geologist cracking open a rock and testing its isotopic ratios. What they find is peculiar, an anomaly, a global spike of radionuclides at one narrow slice of geological history. To them, it is unmistakable. Something happened, something unnatural, something that left behind a chemical signature impossible to explain by volcanoes or by cosmic rays or by meteor impacts. It was civilization. It was you. But nuclear waste is not the only trace. Consider heavy metals. In your quest for industry, you pulled from Earth's crust vast quantities of lead, mercury, cadmium, and rare earth elements. You concentrated them in ways nature never did, dispersing them into soils, rivers, and oceans. Over time, they settle into sediments, forming enriched layers. In 100 million years, these layers fossilize. To any future intelligence, they will stand out. Unnatural enrichments, chemical scars marking a civilization that mined and scattered the bones of its planet. Now turn to your obsession with energy. The burning of fossil fuels has altered the ratio of carbon isotopes in the air, oceans, and soils. Normally, Earth maintains a delicate balance of carbon-12 and carbon-13. But your burning of ancient plant matter floods the system with light carbon, leaving an isotopic fingerprint. Already, geologists call this the Anthropocene signal. In 100 million years, this fingerprint will remain in limestones, coals, and shells, a lasting record of your civilization's brief blaze of combustion. And then there are the plastics, not just in bottles and bags, but in microfibers, microbeads, and invisible fragments. Buried, pressed, and mineralized, they fuse with natural materials to form plastiglomerates. These strange hybrid rocks, half natural, half artificial, will endure for millions of years. Imagine a fossil collector of the far future holding such a stone. In their hand is not a shell, not a mineral, not a bone, but the mingling of humanity and geology. an artificial rock that testifies to an age of industry. Even your electronic age leaves its mark. Rare earth elements mined in vast quantities for screens, batteries, and circuits now spread through the environment. These elements, unusual in concentration, are embedded in sediments. A thin layer rich in neodymium, yttrium, and lanthanum whispers of glowing screens, satellites, and microchips. Long after the devices corrode, the chemical scars remain. But perhaps the most haunting trace is this: the shadow of catastrophe. Nuclear tests scattered across deserts, islands, and oceans leave more than isotopes. They leave glass. When sand is vaporized by an atomic blast, it fuses into glassy green stones. Trinitite, born from the first detonation in New Mexico, is but the beginning. Across the globe, at test sites, in atolls, in remote deserts, this artificial glass is buried. In 100 million years, much of it may endure. Shards of fused minerals that speak of fire no volcano ever made. Pause and feel the weight of this. Your temples crumble, your towers fall, your words vanish. But your waste, your pollution, your experiments with the atom, they endure. The irony cuts deep. What you meant as disposable becomes immortal. What you meant as destructive becomes your monument. And yet there is something profound in this. For even in 100 million years, when your languages are dead and your maps erased, the rocks will still whisper of you. Not in stories, but in isotopes. Not in monuments, but in chemistry. Not in faces carved on stone, but in atoms rearranged by intelligence. It is a strange kind of immortality. Cold, silent, yet undeniable. And so, when the beings of the far future, whoever they may be, study these anomalies, they will know. They will know that once here, on this planet, a civilization walked. A civilization that reached into the atom, mined its world, altered its chemistry, and vanished. Your monuments crumble, your cities fade, but your atomic signatures, the ghostly whispers of your nuclear age, may be the clearest message you leave behind. Close your eyes and listen, not to the wind or the seas, but to the silence left when species vanish. Civilization does not only leave ruins and chemical scars, it leaves absences, the disappearance of creatures, the sudden thinning of forests, the quiet collapse of ecosystems. These absences, too, are recorded in stone. Right now, in your age, countless species vanish under the weight of human expansion. Amphibians, birds, mammals, fish, insects, all fading faster than at almost any time in Earth's history. Scientists already speak of a sixth mass extinction, unfolding not over millions of years, as most extinctions do, but in mere centuries. To deep time, this is a blink, an event as sudden as the asteroid that ended the reign of dinosaurs. Now imagine 100 million years from now. Future paleontologists, whatever form they take, dig into rock layers. What do they see? A sudden drop in biodiversity. Fossil beds rich with many species, suddenly replaced by fewer. Entire families of creatures vanish, their record ending abruptly. To these paleontologists, the pattern will be unmistakable, a mass extinction. But unlike the asteroid at the Cretaceous boundary, this extinction carries peculiar markers. It is tied to carbon shifts, to plastics, to isotopic anomalies, to signs of climate change. The story is clear. A civilization once flourished, and its impact cascaded across the living world. Consider corals. In your oceans, reefs are nurseries of life, building vast limestone skeletons. Today, they bleach under warming seas. Tomorrow, they die. Fossilized reefs will show this story. A sudden change in growth, a collapse in diversity, an interruption that lasts thousands, even millions of years. In deep time, this pattern is a scar, a moment when the ocean's ecosystems broke. Or look to mammals. Many species you know, elephants, rhinos, big cats, whales, are threatened. Their fossils may end abruptly in this layer. To future eyes, it will look like the sharp extinction of giants, mirroring the sudden disappearance of mammoths and saber-toothed cats at the end of the last ice age. But here, it is not natural cycles. It is civilization's shadow. And humans themselves, will you fossilize? In rare cases, yes. Cemeteries may leave traces. Catastrophes, cities buried in mud, victims trapped in ash, may entomb bones that mineralize. but more likely the record of your species is thin. A tooth here, a skull there, fragmentary, scattered, rare, yet unmistakable. For unlike any other creature, your fossils will appear alongside artifacts, metal shards, plastics, glass. Fossils of humanity may not only show bone, but the tools and debris of industry. No other species leaves such a record. Pause here and let the weight settle in. The fossil record is not only about what endures, it is about what vanishes. When trilobites disappeared, their absence was a signal. When dinosaurs vanished, their absence marked a boundary. And when countless modern species vanish in your time, their absence too becomes a marker. Future geologists will know. Here, something extraordinary happened. A civilization lived, burned bright, and triggered extinction. Yet extinction is never the end of life's story. It is the beginning of another. From the collapse of ecosystems come opportunities. New niches open, survivors adapt, evolution writes new forms. Just as mammals rose after dinosaurs fell, new creatures will rise after your era's collapse. In 100 million years, the Earth may be populated by beings you cannot imagine. Descendants of rodents, birds, insects, or even creatures that live unnoticed today. And those creatures themselves will carry your fingerprint. Their bones, their shells, their chemistry will contain traces of the altered world you left. Carbon isotopes enriched unnaturally, DNA shaped by selective pressures you imposed. Even their evolution will whisper of you. In this way, life itself becomes your fossil. Imagine for a moment a bird-like creature evolving 50 million years from now, adapted to a world of higher temperatures, different oceans, altered landscapes. Its lineage survived because you changed the climate. Its existence is tied to you. Its bones, fossilized 100 million years later, bear isotopic ratios altered by your combustion of fossil fuels. In a sense, the creature itself is your monument, not carved in stone, but written in DNA and preserved in fossils. And then consider this haunting possibility. Humanity may not vanish entirely. Perhaps descendants, transformed, adapted, changed beyond recognition, still walk the earth in 100 million years. They would not be you. They would not know your languages, your monuments, your names, but in their bones, in their very being, they would carry your shadow. Civilization would not be remembered in ruins, but in bloodlines. The fossilized shadow of life is perhaps the most profound of all traces, for it does not merely say civilization was here, it says civilization altered the path of life itself. It says, from this point forward, Earth was changed, your monuments fall, your cities fade, but the story of you will be written in extinction, in fossils, in evolution itself, and that story will endure, not in words, but in bones. Close your eyes for a moment and try to imagine 100 million years. Not a century, not a millennium, not even the 10,000 years that span all of recorded history. No, stretch your mind far beyond that. 100 million years is almost inconceivable. It is enough time for mountains to rise only to crumble into dust. It is enough time for oceans to advance and retreat like the slow breathing of the planet itself. Entire species, entire families of life could be born, flourish, and then vanish forever in that span. And yet, you ask yourself, what of us? What of our cities, our technologies, our mighty symbols of progress? What would be left of this civilization after such a colossal gulf of time? You live in a world where skyscrapers touch the clouds, where aircraft carve the sky, where satellites circle the earth. You see roads stretching endlessly, dams bending rivers to human will, and nuclear plants humming with controlled fury. But in the face of geologic time, all of this feels fragile, ephemeral, like sandcastles before the incoming tide. Consider this. The Great Pyramid of Giza is about 4,500 years old. Already, wind and sand have begun their patient work of erosion. Now multiply that by 20,000. Multiply it again. Would anything still stand? 100 million years is older than the great extinction that ended the reign of the dinosaurs. If you walked back that far, you would find a world unrecognizable. strange reptiles in the seas, massive ferns and cycads in thick jungles, continents scattered in different places than they are today. If such changes can happen to the Earth in that span, what hope do human creations have? And yet the story is not so simple. While the winds, the rains, the earthquakes, and the seas all conspire to erase us, traces linger, some fragile, some enduring, some almost eternal. You stand at the edge of imagination, gazing forward into a world where humanity is long gone, but its shadow remains written into the very geology of the Earth. The first thing to go would be the most visible. Our cities, our monuments, our glass towers, and sprawling suburbs, these would crumble quickly. A century without maintenance and steel bridges collapse. A few thousand years and concrete buckles into rubble. Within 10 million years, all of it would be nothing more than faint discolorations in the rock, scattered fragments ground into dust. But the deeper you look, the more you begin to see the stubborn fingerprints of civilization. Deep beneath the soil, plastic polymers might fossilize into strange, shiny seams. Buried landfills could harden into bizarre layers of future geology, what scientists today already call the plastiglomerate. In the oceans, radioactive isotopes from nuclear tests would leave faint but unmistakable signatures, embedded into sediments like time-stamped scars. And stranger still, some things might endure beyond even that. Certain bronze statues, buried and sealed in sediment, could survive, transformed into greenish fossils, their shapes distorted but still recognizable. Some stainless steels, preserved under the right conditions, might remain intact. And then there is the possibility of something far more profound: the fossil record of us. Our bones, our skeletons, perhaps even traces of our DNA, entombed in stone, waiting to be discovered by whatever intelligence might come after. You realize with a shiver that our greatest monuments may not be our cities at all, but the thin layer of geological evidence we leave behind. A band in the Earth's crust, rich with plastic, carbon soot, radioactive isotopes, and the bones of billions. To some future mind, this would be unmistakable, the calling card of a civilization that rose, flourished, and vanished. So as you stand here, gazing across time, you feel both small and infinite. Small because all you know, your streets, your home, your culture, will vanish. Infinite because something of you, of us, will endure. Perhaps not in the way we imagine, but in a way the Earth itself will remember. 100 million years from now, a mountain may rise where your city once stood. Forests may cover what was once a vast plain of concrete. Oceans may lap against lands that are dry today. And yet, deep in those stones, a thin layer will whisper, "They were here." The question you face is not simply what will last, but what will matter. For in the end, time is the ultimate sculptor, and humanity is but one of its many fleeting works. Close your eyes for a moment. Imagine the clock of history, not ticking in seconds or years, but in vast, incomprehensible spans of geological time. You are about to step across a threshold where human memory, human stories, and even human monuments dissolve into whispers carried by stone and soil. You are traveling forward, not a mere 100 years, not even 10,000, but 100 million years. Pause and let that number settle in your mind. 100 million years. It is not just longer than civilization itself. It is longer than mammals have been dominant on Earth. It is a timescale that stretches beyond the lifespan of continents, beyond the rise and fall of mountain ranges, beyond the slow drift of oceans. And yet you ask yourself, what would remain of us? What would survive of our cities, our machines, our monuments, our so-called triumphs? Would anything endure long enough to speak for us when no one is left to listen? At first, your mind leaps instinctively to the obvious markers of civilization. You picture skyscrapers, those towering monuments of steel and glass that pierce the skies of the 21st century. You imagine them standing, empty but proud, like stone giants waiting for recognition. You imagine concrete bridges, massive dams, sprawling highways carved across continents, and the glimmer of space-age technology buried within the crust. But the truth arrives swiftly and brutally. Time is the greatest eraser. 1 million years is enough to crumble steel into dust, to turn reinforced concrete into softened limestone fragments. 10 million years is enough to grind mountains into hills. And 100 million years? By then, entire coastlines will have shifted, oceans will have flooded and receded, and tectonic plates will have rearranged the face of the world. Your grandest skyscrapers, your most defiant monuments, they will be as fragile as a seashell on the shore of eternity. Yet not all is lost, for if you walk deeper into this vision, if you let yourself wander across the transformed earth of 100 million years hence, you begin to notice that traces do linger. Not in the obvious places, not in the towering forms of architecture, but in hidden layers, in buried signatures, in strange and silent fossils of human ambition. Picture the ocean first. Today, beneath its restless waves lie mountains of plastic, rivers of microfibers, and the silent wreckage of ships, aircraft, and submarines. Most of that plastic will not last 100 million years. It will be broken down by sun, water, and microbes, dissolved into chemical ghosts. But some of it, trapped in oxygen-deprived sediments at the seafloor, may become immortalized, fossilized within new rock layers. In the geologic record, scientists of some distant species may one day find thin black streaks of polymer-rich shale, plastic rock, the calling card of our time. Now turn your gaze to land. What of the great cities? What of Rome, New York, Beijing, or Cairo? Their proud walls will fall, their streets will vanish under forests, deserts, or oceans. But beneath the shifting soils, under meters of compressed sediment, traces may remain. Foundations of concrete could be chemically altered, but their outlines may be preserved like shadows in stone. Rusted remnants of bridges may leave iron oxide stains within the crust. Even subway tunnels, those deep burrows carved into bedrock, could collapse, then fossilize, leaving empty voids, peculiar cave systems in the rock record, perhaps forever unexplained. You cannot forget the atomic signature either. For if you could peel open the strata of Earth 100 million years from now, you would see more than stone and clay. You would find isotopes that should not exist, uranium and plutonium residues from nuclear weapons tests, artificial elements scattered in microscopic abundance. They will persist far longer than steel or glass, subtle chemical fingerprints etched into Earth's memory. Perhaps this, more than any crumbled ruin, will declare, something powerful once lived here. Your heart trembles as you consider life. For civilization has not only left monuments of stone and steel, it has altered biology. Domesticated crops, engineered plants, livestock selectively bred over thousands of years. What becomes of them? In 100 million years, species evolve, mutate, and vanish. Dogs may no longer exist as you know them. Wheat, corn, rice, these staples may be long gone. Yet fossils of cattle bones in mass graves, the strange density of chicken remains. Yes, chickens, the most abundant bird of human history, may tell a story of an age when one species bent nature to its will. Paleontologists of the future, if they exist, will one day uncover these remains and name them not individually, but collectively as an Anthropocene fossil assemblage. And then there are the satellites. Lift your eyes, for the Earth is not the only canvas of memory. Orbiting silently above the planet today are thousands of satellites, space stations, fragments of machinery. Over decades, they will fall, burning into dust. But some, cast farther into space, may drift for millions of years, cold and forgotten. The Voyager probes perhaps may still wander, carrying golden records that no one is left to hear. In 100 million years, they may still exist, farther from Earth than any monument of stone or steel could ever travel. Strange, isn't it, that our most lasting legacy may not be on Earth at all? As you breathe in this vision, a mixture of awe and sorrow floods you. You realize how fragile civilization is when measured against geologic time. You realize how arrogant it is to think our cities eternal, when mountains themselves erode to dust. And yet, you also feel wonder, because though most will vanish, not all will. We will leave behind layers, signals, and scars in the earth itself. We will be part of the geologic record, as real as the dinosaurs, as undeniable as volcanic ash. And so, as you take your first step into this 100 million year journey, you carry a truth heavy with paradox. Civilization will be forgotten, and yet it will never be entirely erased. Its ruins will crumble, but its fingerprints will linger, etched in stone, in chemistry, in fossils, and in the silent drift of machines through space. You, standing here in the present, are already writing history in the rocks of tomorrow. This is where your journey begins. 100 million years into the future, searching for the ghost of a species that once dared to imagine it would last forever. You stand now in the ruins of imagination, trying to picture what happens when human cities are carried forward across the abyss of deep time. Think of New York, with its steel skyline piercing the clouds. Think of Paris, with its Eiffel Tower rising in elegance. Think of Dubai's gleaming towers and Tokyo's endless lights. At first, you might imagine them lingering, silent and ghostly, like stone pyramids waiting for rediscovery. But this is the first illusion you must shatter. Cities are temporary, heartbreakingly temporary. Take New York. In just a few centuries without maintenance, water seeps into foundations, subway tunnels collapse, and glass towers crumble. Bridges rust, concrete cracks, and within 1,000 years, the once proud city becomes a forest of ruins. Ivy and oak trees reclaim the streets, rivers carve through avenues, and skyscrapers collapse into heaps of rubble. By 10,000 years, only faint mounds remain, buried beneath sediment and roots. By 1 million years, even those mounds are erased, ground into the soil by glaciers, rivers, or seas. And by 100 million years, not a single tower will stand. The continent itself will have shifted. Ocean and mountain will decide what survives, not architecture. But do not lose hope. Cities do not vanish entirely without trace. They are translated into the language of geology. Concrete, though fragile on the surface, leaves behind unusual chemical residues, calcium silicate hydrates, that may fossilize within new rocks. Steel, oxidized and dissolved, becomes thin red bands of iron-rich deposits. Even glass, shattered and melted, may fuse into strange mineral forms akin to volcanic obsidian preserved as accidental stones. In future strata, there will be layers bearing peculiar textures, foreign to natural geology, human-made, unmistakably artificial. Now imagine Cairo. The Great Pyramids, often thought of as eternal, would fare no better. Their limestone blocks erode under relentless winds. Sand buries them, then grinds them down grain by grain. 100 million years from now, their once perfect geometry will be lost. At best, a faint triangular mound might remain, indistinguishable from natural hills, unless preserved beneath sediment. Perhaps, if fortune aligns, a cross-section of pyramid stone may be caught in a riverbank cliff or an exposed ridge, confusing paleontologists of a future species. Was this natural layering? They might wonder. Or perhaps, was this the mark of intelligence? Travel now to Rome. The Colosseum, that ancient circle of empire already weathered by 2,000 years, will not outlast 10 million more. Yet the bones of its foundations, embedded deep into volcanic soil, may persist as hardened inclusions. Tunnels, amphitheaters, aqueduct bases, all will collapse, but their ghosts may linger underground, protected in sediment. Imagine geologists of the distant future cutting through bedrock, finding peculiar semicircular patterns of stone, out of place, inexplicable. They might speculate, what animal built such nests? What phenomenon carved such arcs? Never knowing that it was once the heart of entertainment for a vanished people. Shift your gaze to the east, to Beijing, with its great wall stretching like a dragon across the land. Surely this, massive and sprawling, would last. But stone is not eternal. Frost shatters it, plants crack it, erosion eats it. In 1 million years, it is rubble. In 10 million, even the rubble is dust. By 100 million, only the faintest lines in the soil might hint at its former path. If preserved beneath layers, perhaps geologists would one day uncover an anomalous line of stones running for hundreds of kilometers, a mystery to interpret, a forgotten barrier between worlds. Yet even that is uncertain. And what of modern marvels? The towering dams of Hoover, the bridges of San Francisco, the tunnels beneath the English Channel, they too will vanish. Concrete dams, though vast, crumble under pressure, earthquakes, and erosion. Rivers reclaim their flow, washing away evidence. Bridges collapse, their steel gone to rust, their concrete gone to dust. Tunnels collapse, sealed beneath layers of silt and rock until they are indistinguishable from natural caves. The grandeur of engineering, once thought unbreakable, dissolves like chalk in rain. But here's the paradox. You will not leave behind cities in their visible form, yet you will leave signatures that cannot be mistaken. Beneath ancient seabeds, there will be unusual concentrations of synthetic compounds, plastics, metals, alloys never seen in nature. Aluminum, for instance, is rare in natural form, and yet humans refined it by the billions of tons. In 100 million years, geologists will find aluminum deposits in places where no natural process could have placed them. They will know something was here. There is also the matter of carbon. The fossil record of human civilization is not only built of stone and steel, but of atmosphere. By burning coal, oil, and gas, you have altered the balance of carbon isotopes. That change is etched into sediments forming right now, sediments that will harden into rock. In 100 million years, the thin band of rock that represents our time will reveal an unusual spike of carbon, unlike anything before or after. It will be a chemical scar, a fingerprint written into Earth's diary. Anyone reading the rock layers would see it. They would ask, what caused this sudden change? What force disrupted the balance of life so dramatically? And perhaps the answer, hidden among fossilized bones of cattle, pigs, chickens, and humans themselves, would whisper back, civilization, a species that dreamed it could last forever. You cannot ignore the emotional weight of this realization. For on one hand, it humbles you, your cities, your towers, your monuments, all destined to vanish. But on the other, it reassures you, you will not be forgotten entirely. You will not be erased like breath on glass. You will leave behind traces, subtle but undeniable, folded into the very crust of the earth. Not legible to memory, perhaps, but legible to science. And as you let that thought settle, you begin to see civilization not as a permanent empire of monuments, but as a brief, blazing experiment. Its ruins do not last, its echoes do. And in 100 million years, when new continents rise, new oceans form, and perhaps new species walk the earth, your cities will live again, not as buildings in sunlight, but as clues buried deep, waiting for discovery. The disappearance of cities is not the end. It is only the first stage in civilization's transformation, from architecture to geology, from memory to fossil, from presence to signature. And this realization is both haunting and beautiful.